In this video, we'll be learning about our network security and segmentation checklist. I'm Chris, CSJ Code, cloud architect and founder of systemsarchitect.io and codeguides.io. Network segmentation divides your cloud network into isolated zones with controlled paths between them. Why is a flat network dangerous? A flat network, where every workload can reach every other workload, hands attackers free lateral movement after the first compromise. Proper segmentation contains breaches, limits blast radius, and enforces least privilege at the network layer. This checklist covers 10 practices for defensible networks applicable on AWS, Azure, and Google Cloud Platform. 1. Default deny all traffic. 2. Segment by workload tier. 3. Use private subnets only. 4. Eliminate public endpoints. 5. Filter egress aggressively. 6. Deploy WAF on all ingress. 7. Enable DDoS protection. 8. Use private endpoints and services. 9. Log and alert on denied traffic. 10. Review rules quarterly. This presentation is a condensed version of the complete article on blog.systemsarchitect.io. View the full blog article with more details there. First, default deny all traffic. Start every security group, network ACL, and firewall policy with a deny all baseline. Then open only specific ports to specific sources with a documented owner and business reason. What does default allow really cost? Default allow means every new service is reachable until someone reacts with a deny rule after an incident or audit. Default deny forces each allow to be justified, which is how you keep rules reviewable. Template new workloads with all inbound and outbound denied. Require requests to open paths and tag every rule with purpose and approval link. On AWS, security groups deny inbound by default, but allow all outbound until you tighten them. Network ACLs are stateless, so deny broadly and add numbered allows. And use VPC endpoints to avoid needless internet egress for platform APIs. On Azure, NSGs ship with some broad defaults. Put explicit denies at the lowest priority and specific allows higher, and use application security groups to manage large estates. On GCP, implicit deny all ingress is helpful, but override allow all egress with an explicit deny all egress. Then open only needed paths and use hierarchical firewall policies for org-wide baselines. Second, segment by workload tier. Split web or presentation, application logic, and data into their own subnets with rules that only allow the next hop on the right ports. What if the tiers share a subnet? If web, app, and database share one subnet, a compromised front end already sits on the database network. Web should talk to app on defined ports and never open database ports like 3306 or 5432 directly. Create at least 3 subnets per availability zone. Public for load balancers only, private app for compute, and private data with no internet route. Reference adjacent security groups or tags instead of wide CIDRs. CIDR or CIDR is classless interdomain routing, a method for allocating IP addresses and routing. NAT, network address translation, is a method that maps private IP addresses to public ones for outbound traffic. On AWS, public routes to an internet gateway, app via NAT, data with no NAT, and database groups only accept the app group as source, verified with VPC flow logs. NSG, network security groups, are Azure's stateful firewall for controlling traffic to and from resources. On Azure, NSG chains like 443 to web, 8080 from web to app, and database ports only from app. with Azure Firewall or NVA between tiers when you need deep inspection, and Bastion for management. Azure Bastion is a managed service for secure RDP and SSH access. On GCP, Google Cloud Platform use network tags such as web tier, app tier, and data tier with allow rules from app to data on the database port, plus private Google access so data subnets reach APIs without public internet. Third, use private subnets only for compute. Put VMs, containers, and functions in private subnets. Only load balancers and API gateways belong in public subnets as controlled front doors. A public IP on compute is internet addressable forever, and one security group mistake becomes scanning and brute force. Private placement removes that surface so traffic arrives only through the load balancer with TLS, Web Application Firewall, and health checks. Use NAT for limited outbound, prefer platform private endpoints for cloud APIs, and manage shells with SSM Session Manager. Azure Bastion or GCP IAP without opening port 22 to the world. Identity Aware Proxy is Google Cloud Service for controlling access to applications and resources. Systems Manager is AWS service used for secure instance management without SSH. Fourth, eliminate public endpoints on PaaS. Platform as a Service is a cloud computing model providing hardware and software tools over the internet. Databases, caches, storage, and queues should not face the internet. Use Private Link, Azure Private Link, or Private Service Connect so only your VPC path can reach them. Public RDS or Open Object Storage is a standing invitation to brute force, probes, and misconfiguration breaches. Private endpoints remove public IPs and internet paths to scan. Audit with Access Analyzer, Defender for Cloud, or Security Health Analytics. Deny public creation by org policy and start with the data tier. Disable publicly accessible flags on managed databases and attach private endpoints with private DNS so apps keep normal host names. Fifth, filter egress aggressively. Unrestricted outbound lets a compromised host exfiltrate data, pull malware, and talk to command and control over ports that look normal, like 443 or 53. Allow only needed destinations. Use VPC endpoints for cloud services. Put external APIs behind an allow list proxy or cloud firewall. Block casual SMTP, open DNS except to your resolver, and SMB. Log outbound connections for anomalies. On AWS, Network Firewall supports domain-based egress rules. Simpler estates can at least tighten security group outbound CIDRs. On Azure, Firewall Premium does FQDN filtering and threat intelligence blocks. On GCP, Firewall by IP and port plus a proxy for FQDN needs, with Cloud NAT logs showing who talked where. Sixth, deploy a web application firewall on every public ingress path. Application attacks ride valid HTTP on 443 and skip network rules. OWASP Top 10 still drives real breaches, so managed rule sets catch known patterns before your code is the only defense. Run count or log mode for 2 to 3 days, fix false positives, then block. Scope heavy body inspection to user input routes and skip static assets to cut cost and noise. On AWS, attach Web Application Firewall to CloudFront, ALB, API Gateway, or AppSync with common SQL injection and known bad input rule groups. On Azure, Front Door or Application Gateway Web Application Firewall with managed rule sets, log mode overrides, rate limits, and geo blocks. On GCP, Cloud Armor on load balancers with pre-configured SQL injection, XSS, and path traversal rules preview mode, and adaptive protection for application layer floods. XSS cross-site scripting is a common web application vulnerability. Seventh, enable DDoS protection on every public face. Volumetric floods can overwhelm any single deployment. Provider edge capacity absorbs L3 and L4 attacks, while L7 floods need web application firewall rate limits and adaptive detection. Put public endpoints behind CDN or global load balancing. Combine with web application firewall rate limits and test annually so first contact is not production chaos. AWS Shield Standard covers baseline L3 and L4 free. Shield Advanced adds deeper mitigation, response team access, and cost protection for covered resources. Azure DDoS network protection profiles whole virtual networks. IP protection fits smaller scopes, both with monitor visibility. GCP gives L3 and L4 protection on global load balancers with Cloud Armor, and Managed Protection Plus adds adaptive L7 defenses. Eighth, use private endpoints and private services for cloud APIs and data planes. Why prefer private paths? Internet paths to storage, databases, and secret managers add latency, interception risk, and routing exposure. Private paths stay on the provider backbone and help compliance for data in transit. Prioritize storage, databases, and secret managers first. On AWS, free gateway endpoints for S3 and DynamoDB are easy wins. Resolve public host names to private IPs with private DNS so apps need no code change. Azure Private Link plus private DNS zones keeps connection strings stable. GCP Private Service Connect and Private IP for Cloud SQL remove public assignment while keeping API access inside the VPC. Ninth, log an alert on denied traffic. Why log every deny? Every deny is either your own misconfiguration or someone else's scan. Without logs, both stay invisible. Alert when denials involve your own CIDRs for ops fixes, and when external denials spike for security. Baseline over 2 to 4 weeks, so 10,000 denials per minute stands out from normal noise. On AWS, VPC flow logs filtered to reject into CloudWatch with insights queries and alarms. On Azure, NSG flow logs and traffic analytics, with monitor queries on denied flow status. On GCP, subnet flow logs filtered to denied, export to BigQuery, and monitoring alerts on log-based metrics. 10th, review rules quarterly. Rules accumulate. Temporary debug holes become permanent. Migrations leave dead allows, and after a year, nobody owns the mesh. Pull current rules, last hit data, and ages. Delete unused after owner check. Tighten any 0000/0. Require comments, owners, and expirations. Manage via infrastructure as code so changes go through pull requests. On AWS, Reachability Analyzer, Security Hub for open groups, CloudTrail for changes, and diffs against Terraform state. On Azure, Network Watcher effective rules, traffic analytics for unused rules, and policy for internet-sensitive ports. On GCP, Firewall insights for permissive, shadowed, and unused rules, plus hierarchical policy for central visibility. To close, start with default deny and tiered private subnets so compromise cannot wander sideways through a flat mesh. Strip public IPs from compute and PaaS, force private paths, and treat egress as carefully as ingress. Put web application firewall and DDoS in front of every public door. Keep private endpoints for sensitive services and log denials so misconfig and scanning surface early. Review the rule set every quarter so segmentation stays intentional, not a museum of forgotten exceptions. Those 10 practices turn network security from a flat trust zone into a layered defense on AWS, Azure, and GCP. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.